Hello to my doctor, Dr. Nazri. My name is Avinash. My matrix number is S56952. And today, the first presentation I'm going to make is about thyristor, IGBT, and also ICS. Okay, first I'm going to start with thyristor. What is a thyristor? A thyristor is a 4-layer device with alternating P and N type semiconductors. It actually has 3 terminals, which is anode, the positive side, cathode, the negative side, and also gate, which is the control terminal. What is the function of a thyristor? The function of the thyristor is to control the electric power and current by acting as a switch. It has 2 states, which is forward blocking state and reverse blocking state. Okay, what are the characteristics of a transistor? Okay, the characteristics of a transistor is it has a anode and cathode that are connected to the supply voltage through the load. Another secondary supply is applied between the gate and to the cathode of the terminal. Okay, moving on. Reverse blocking mode of the transistor. As I stated just now, there are 2 modes for this transistor, and the first one is a reverse blocking mode. Okay, what is a reverse blocking mode? Okay, in reverse blocking mode, the cathode is made positive with respect to anode by supplying voltage E, and the gate to cathode supplying voltage ES is detached initially by keeping the switch open. For understanding this mode, let's have a look at the figure that I have stated below. Referring to the figure, here junction 1 and 3 are reverse biased, whereas the junction 2 is forward biased. The behavior of the transistor here is similar that of 2 diodes are connected in series with the reverse voltage applied across them. Okay, as a result, only a small leakage current of the order of a few UAMPS flows. Okay, reverse blocking mode or the off state of the transistor. If the reverse voltage is now increased, then at a particular voltage known as the critical breakdown voltage, an avalanche occurs at J1 and J3, and the reverse current increases rapidly. A large current associated with VBR gives rise to more losses in the SCR, which results in heating. This process may actually lead the transistor damage, as the junction temperature may exceed its permissible temperature rise. It should therefore be ensured that the maximum working reverse voltage across a transistor does not exceed the VBR. For the next mode, we are going to look at forward blocking mode. Okay, forward blocking mode is actually where the anode is positive with respect to the cathode, with the gate kept in open condition. Only a small current called forward leakage is allowed to flow. When the anode to cathode forward voltage is increased with gate circuit open, the reverse junction J2 will have an avalanche breakdown or forward breakdown voltage, leading thyristor to turn on. Okay, let's have a look at the example. The example that I took for the thyristor is SCR. Okay, SCR is actually a silicon controlled rectifier or semiconductor controlled rectifier, which has a 4-layer solid state current controlling device. SCR are unidirectional devices, and it can conduct current only in one direction. The next one I would be presenting is IGCB, which is insulated gate bipolar transistor. Okay, this actually consists of BJT and also MOSFET. It is a three-terminal semiconductor switching device that can be used for fast switching with high efficiency in many types of electronic device. An IGBT features a significantly lower forward voltage drop compared to a conventional MOSFET in higher blocking voltage rated device. The collector and the emitter are actually the conductor are actually the conduction terminal. The gate is the control terminal with which the switch operation is controlled. Okay, how it works. Okay, first of all, the junction 1 would be forward bias, the junction 2 will be the reverse bias. You can refer to the diagram that I have stated. Since J2 is in reverse bias, there will not be any current flowing inside the IGB. Okay, when the applied gate voltage, the negative ion will get accumulated on the upper side of the layer, and the positive ions will get accumulated on the lower side of the SOI2 layer. This causes the insertion of negative charge carries in the P region. Higher the applied voltage, greater the insertion of negativity charge carriers. This actually also leads to a formation of the channel between the J2 junction, which allows the flow of current from the collector to the emitter. When the applied gate voltage Vg increases the amount of the current flow, the collector to the emitter also increases. Here you can see the types of IGBT. There are actually two types of IGBT. One is PT IGBT, which is also known as punch through IGBT. The second one would be NPT IGBT, which is called non punch through IGBT. So what are the difference between both of these? Okay, PT IGBT has the N plus buffer layer, and NPT IGBT does not have the N plus buffer layer. That is actually one of the difference, and you can refer the table below for more differences. Okay, for application, where are GBTs used? GBTs are widely used as switching devices in the inverter circuit for driving small to large motors. IGBTs for inverter application are used in home appliances such as air conditioners, refrigerator, industrial motors, and automotive main motor. So this is basically the application. And for my final subtopic is actually integrated circuit. Okay, we are all very familiar with integrated circuit. Okay, an integrated circuit, or also known as IC, is a small chip that can function as an amplifier, oscillator, timer, microprocessor, or even a computer memory. An IC is a small wafer. Usually it's made up of silicon that can hold anywhere from hundreds to millions of transistors, resistors, and capacitors. Okay, how it works. IC circuits are actually a combination of diodes, microprocessors, and transistors in a minimized form on a wafer made of silicon. These components are used to store voltage or circuit stabilizers. They can be used to amplify the given signal and used as switched working in digital circuits. There's two types of ICs actually. Analog IC, where the input and output both signal are continuous. Second one is digital IC, where the logic gates, microprocessors are some well-known examples of digital ICs. Application for ICs. Basically, IC is a very common electronic device. You can see IC in computers, mobile phones, and other digital home appliances. For example, you can basically see ICs in most of the electronic device. That's all for my first presentation. Thank you. Now for my second presentation, I'm going to be presenting about photodiode, LED, and laser diode. Okay, first I'm going to start with photodiode. What is a photodiode? Okay, it is actually a form of lightweight sensor that converts light energy into electrical voltage or current. Photodiode is a type of semiconducting device with PN junction between the P and N layers, An intrinsic layer is presented. For your information, P is positive while N is negative in the PN junction. The photodiode accepts light energy as input to generate electric current. So based on the both figure, you can see the photo of the photodiode. Okay, how it works. Photocurrents are produced due to generation of electron pairs. When the photon enters the depletion region of diode, it hits the atom with high energy. An electron will have a negative charge and holes will have positive charge. The depletion energy will have built in an electric field. The photon absorption intensity and the photon energy are directly proportional to each other. Uh, it it actually has three modes, which is photovoltaic mode, photoconductive mode, and also avalanche diode mode. First of all, this is actually the figure of how it works. Okay, first of all, for photovoltaic mode, okay, this is otherwise known as zero bias mode. When a photodiode operates low frequency applications and ultra level light applications, this mode is preferred. When photodiode is irradiated by flash of light, voltage is produced. The voltage produced will be in a very small dynamic range and it has non-linear characteristics. When photodiode is configured with OP-AMP in this mode, there will be a very less variation with the temperature. So this is actually the image of the photovoltaic mode. Nextly, photoconductive mode. Okay, in this mode, photodiode will act in reverse biased condition. Cathode will be positive and anode will be negative. When the reverse voltage increases, the width of the depletion layer also increases. Due to this, the response time and junction capacitance will be reduced. Comparatively, this mode of operation is fast and produce electrical noises. Transimpedance amplifiers are used as preamplifiers for photodiodes. Most such amplifiers keep the voltage maintained to be constant to make the diode operate in the photoconductive mode. For the final mode, it would be avalanche mode. In this mode, avalanche diode operates at a high reverse bias condition. It allows multiplication of avalanche breakdown to each photo produced electron hole pair. This produces internal gain within photodiode, and also the internal gain increases the device's response. Okay, for application, where are photodiodes used? Photodiodes are applied in safety electronics like fire, smoke detectors. You can also see it in TV units. Photodiodes are widely used in numerous medical applications too. For example, blood gas monitors. Okay, the next subtopic is LED. Okay, LED. LED is a semiconductor device that emits light when an electric current is passed through it. Light is produced when the particles that carry the current, known as electrons and holes, combine together within the semiconductor material. It is a specific type of diode having similar characteristics as the PN junction diode. How it works: a light emitting diode is a 2-lead semiconductor light source. It is an PN junction diode that emits light when activated, and a suitable voltage is applied to the light emitting diode. Electrons are able to combine with electron holes within the device, releasing energy in the form of photons. This effect is called electroluminescence, and the color of the light is determined by the energy gap between the semiconductors. For application, for LED is also a very common electronic device. You can look at it in the TV backlighting, smartphone backlighting, dimming of lights, and also to be more common, car lights. The final subtopic that I will be presenting is laser diode, a semiconductor device that generates coherent light of high intensity is known as a laser diode. Laser is an abbreviation of light amplification by stimulated emission of radiation. Stimulated emission is the basis of working of a laser diode. how it works. Basically, it has three processes: absorption, spontaneous emission, and stimulated emission. So first of all, let's look at absorption. Okay, in absorption, in order to have transition from a lower energy to a higher one, the atom requires to overcome the energy difference between two levels given by E2 minus E1. Is where electron jumps to higher energy level on overcoming energy difference, and E1 is where at the left hole after electron moves to the higher energy, which is E2 level, by absorbing energy. The second one would be spontaneous emission. Due to the absorption, the atom is present in the energy level E2. As the lifespan of the atom expires, it now comes back to the ground level from the higher energy level. On coming back to the ground level, the atom emits the energy difference of the two energy levels, for example E2 minus E1. Nextly is stimulated emission. Okay, the atom is present in the higher energy level before the exhaustion of its lifespan. An electromagnetic wave of frequency equal to the frequency of spontaneous emitted atom is provided to the atom. This causes the atom to perform a transition from E2 to E1. Okay, for the next one, what are the applications? Okay, laser diodes are widely used in telecommunication and in defense industry. Optical fiber communication also uses laser beam for signal transmissions, as optical fiber requires highly focused beam. It is highly used in laser printers also. That's all for my slide for my both presentation today. I would like to thank all of you for hearing me out today. Thank you very much.